What's up, y'all? I'm back. I know it's been a minute since I've uploaded a video. I apologize. I really do miss filming these, but things have been crazy busy, which I'm thankful for. It's a good thing. But I figured it was time to press pause and film a video of a repair for you, especially since I have this awesome Hiwatt DR103 in for repair. I haven't documented an amp like this yet, so I'm excited to show it off to you. So, Hiwatt. These amps became popular in the mid to late 60s into the 70s. So this was around the time that Marshall super leads were really popular. Late 60s, you think Hendrix sound. That was super Marshall-y. So these amps were being copied a lot. Hiwatt, not even close to the super lead. The control panels and configurations are kind of similar, two separate channels, but the Hiwatt is so different in comparison. They are louder, cleaner, fuller sounding, less overdrive than a Marshall, but if you have the pleasure to really crank one of these, you'll hear that it does break up nicely when it's real loud. Also, the construction of these Hiwatts is just unparalleled, and that is thanks to Joyce, who designed these amps. He was a military certified wiring engineer, so he really kept these amps up to military spec. What is military spec? A big part of it is if something fails in the field, you can service it right then and there and get it working. Similar with these Hiwatts. It's so easy to replace components and access all the components in the wiring. You'll see when I open it up. It's real clean inside and so easy to service. You don't have to take any boards out. You don't have to take anything apart to get to any components. It's so streamlined. So due to that attention to detail, when it comes to building one of these, they're a lot more scarce than Marshalls. I see way fewer Hiwatts than I do Marshalls in a year, which is sad. I wish I would see more Hiwatts. They're just not around as much. Hiwatt amps are still being made today, which is awesome. I've never opened up one of the reissue Hiwatts, so I've not seen what they look like on the inside. But if it's got the Hiwatt name, I would hope that it would be built with the same integrity as these old guys. So David Gilmour definitely used the DR103. Pete Townsend used Hiwatts, Thin Lizzy, amongst many others. All right, so now I'll give y'all a closer look. All right, so let's take a look at the control panel. We have two separate channels, a normal and a brilliant. Brilliant is a brighter channel. And it's common to jumper the two channels, and this allows you to combine the channels. So we have the volume for the normal and bright channels. We have bass, treble, mid control, presence, and a master volume. So it's super simple and also very similar to the Super Leads control panel layout, which is why it's assumed a lot of the time that they're very similar amps. And then coming in on the back panel here, we have the mains fuse, which is written here that it should be 5 amps. I have a schematic that says it should be 6.3 amps. However, this amperage rating is for when you're using European voltage. So since we are in the US and we are going to be using 115, that means we need to cut the amperage rating of the slow blow in half. On the schematic I have here, you can see the mains fuse is written as 6.3, so half of that will be around 3.15. I'm going to use a 3 amp slow blow fuse for the mains. And then we have the HT fuse, which is 3 amps. Here you have the voltage selector, so you can use this amp pretty much wherever you'd like in the world. This is the power connector, which is a really weird connector. They do make adapters where you can plug this into the wall. However, CE Distribution sells these IEC connectors, which are supposed to fit in here, so I'm going to try that out so that you can just use a standard IEC power cord. And then here we have the output impedance selector, so it's currently set to be 16 ohms. You can do 8 or 4 as well. These are the speaker jacks and the quad of EL34 output tubes. This tube is bad. It pretty much just lights up like fireworks, so I'm not going to necessarily demonstrate that. I'm gonna give this amp a new quad of VL34s, so we got a nice matched set. And then over here we have the 4 12AX7 preamp tubes, and then we have 4 filter capacitors, which I'm going to be replacing all of them. You'll see why in a moment. And then we have the glorious Partridge transformers made in England. This is the output transformer. This is the power transformer. All right, coming in from the underside. So you can see how pleasing to the eye this layout is. It's so clean. You can like see everything. There's no components hiding anywhere. What you see is what you get here. Some resistors have been changed and some of the big caps have been changed. But I'm just gonna go ahead and change all of the filter caps. And you can see like this one, it's super, super leaky. They're just kind of dried out. This one's starting to bulge. So the bulk of this job is just going to be a recap and then change the tubes and evaluate. Since I am replacing the output tubes, I'll also replace these 100 ohm screen resistors that are on the output tubes, because those can be damaged if a tube fails, which happened in this case. So basically, I'm going to start by doing those caps, resistors. I'm going to install the new power outlet, and then we'll evaluate it and see what else it might need. My guess is that it won't need much more other than, you know, a service. Again, I just want to emphasize how beautifully laid out these amps are. And it just makes my job a whole lot easier and more enjoyable. It also makes these amps more reliable in general. So not only do they sound good, but you have peace of mind that structurally they're very sturdy and secure. You're not going to have like a bunch of random connection issues that are hard to find. So I'm going to begin by replacing this filter cap. It's a 16 microfarad times 2 cap, meaning there's 2 16 microfarad caps in this can right here. And the purpose of this specific cap is to supply the high voltage to some of the preamp tubes, specifically V1 and V2, which are the first amplification stages. All right, so I'm just going to remove the wires. This is one of the positive wires. This red wire is the other positive wire. And then this is the ground connection. All right, and then I loosened this screw, so I'm able to just pull the cap right out. So here's the cap that was in there. English-made cap. Literally all you do is put that new one in there. All right, and then you tighten up the screw so the cap is nice and secure in there. And then all you do is just solder on those wires. So here's a little bit of an up-close look at that new filter cap installed. And now I'm going to replace these 3 caps. 1, 2, 3. And these 3 are just single caps, so they're just top mounted. So we've got the positive and negative terminals. And going over on the other side, you can see them here. So I'll be removing them the same way I just removed that other cap, by just unscrewing and loosening this clamp and then unsoldering the cap, and it'll pull right off. This cap I'm also going to replace, but this is a multi-section one, so I'll do that separately. So on the schematic, it shows these caps are 220 microfarad at 350 volts. The only top mounting caps I could really find were these JJs, 220 at 385. They're a little bit thinner than these caps, but so hopefully the clamp will be able to clamp it in nicely. If not, I can just attach a piece of foam or something to make sure that it's clamped in there. But I'll cross that bridge when I come to it. These caps are in the first filtering stage. So these are the caps that are getting that rectified voltage and smoothing it out initially. All right, since all three of these 220 microfarad caps have parallel 220K resistors running across them, I just decided to install the resistors before I install the caps. It's just easier that way. So then I just have to solder on the wires and that'll be it. So let me just begin by cutting all these wires and removing the three 220 caps. So now I just need to loosen up these caps here. Okay, so as I suspected, these caps are too skinny, so the clamps will not hold them in. I ended up having this adhesive backed Velcro, so I just wrapped it around the cap, gave it a nice little coat, and now it fits in there real snug. Alright, so for the 50/50 cap, I'm using this F&T, and I've got the 220K resistor hooked up from one of the sections to ground. So I'm gonna remove this one and then install this, and then that'll be the last of the chassis mounted caps. We got all the caps replaced except for the bias cap, so I'm going to do that right now. Alright, so now comes the experimental part. I'm going to remove this power socket. It looks like this IEC connector is like just a little bit too big. So just an example of me thinking something through and then finding an even better and easier way of doing it. So after I removed this power socket and realized that this IEC was not going to fit, I realized there's already a hole in the chassis right here for a regular power cord to go in. So I'm going to just reinstall this, leave it unhooked, and then install a power cord and just hook it up the normal way I would install a power cord. Alrighty, so I've got the power cord installed with the strain relief, and I've got it just bypassing the original plug, which I still need to reinstall. And then I've got the ground grounded. Hot wire goes to this terminal on the switch. When the switch is switched on, it'll go to the fuse, amongst other things. And then the neutral wire goes to this part of the switch. When switched on, it connects to the power transformer. So basically, all that's left in this preliminary work here is to replace the 100 ohm screen resistors, and then I'm gonna test her out. And I'm going to do the same exact thing for the other tubes. replace these 100 ohms. Now all of the screen resistors have been replaced, and that is pretty much all of the component replacement that I'm going to do at this point. I'm just going to go ahead and clean all the jacks, pots, and tube sockets, put in a new set of EL34s, and then we'll test her out. Alright y'all, so I've serviced the amp. I've cleaned all of the pots, the jacks, all of the tube sockets. I installed these Tongsol EL34s. These are pretty much all I was able to get with the tube shortage, and they're not bad, so I just decided to go with them. But the bias is way too hot. The current reading I was getting was about like 70 milliamps, which is super, super hot. And there's no bias adjustment in these Hiwatts. So it's kind of a known issue that the stock bias circuits are just set very hot for new tubes, and they're not adjustable. So there is a modification to the bias circuit that will allow it to become adjustable and cool down the bias a little bit, so the tubes won't die after a very short amount of time. So this here is the stock bias circuit. Basically, we have this resistor and diode, which rectifies the low voltage AC out of the power transformer to become DC voltage. And we have this capacitor with the positive lead grounded, so we're creating negative voltage essentially. And this resistor is actually supposed to be a 47K. I had increased it to 68K just to see how much that would cool down the bias, and it didn't really make much of a difference. So anyways, these are the components in the stock bias circuit, and I'm going to modify the circuit using this schematic, which I have used before. Here we have the stock circuit, and I'm going to build this circuit now instead. I'm going to adjust it a little bit just to use parts that I have in stock, and then we'll test it out. But essentially, we're going to be creating an adjustable circuit. This one is also an option. It's just way more complex. So it's creating two separate bias controls, one for each pair of output tubes. All right, so here we go. I am just going to remove these components and rebuild the circuit, and I'll show you guys what I come up with. All right, so here is my new bias circuit. I've installed the bias pot here, which I've secured with silicone glue. I installed a terminal strip right here so that I could have some nice new connections for the added components. I did change a couple of the values just to adjust for what I have here, but I was able to get the bias current to about, we have 33.6 milliamps, which is pretty good for EL34s, and I calculated that based on the plate voltage of the tubes. Another very, very important thing to note here, we have this tap from the power transformer is one of the bias taps, and we also had a second bias tap, which is right here, and it was previously connected to this ground. We want to remove that from ground. It's very important to do so. I just lengthened the wire and brought it up here to where it taps into the bias circuit. And we have AC from the transformer being converted to DC, and we're getting a negative DC voltage that we then feed to the output tubes pin 5. And that is the bias voltage being generated. So all I have to do is rivet in the power plug that I prematurely removed, and this amp will pretty much be finished. right, y'all. Thanks so much for tuning in. I hope you enjoyed this video. It's real good to be back. Don't forget to like and subscribe. I'll see y'all later.